All right, we are back where we left off, and we're going to code review. I mentioned yesterday it should be pretty straightforward because we just copy pasted this, changed a couple things. So let's just go through it anyway. Um, so we don't have any additional using statements. Things good. Let's hop down to concat because that's where things actually started. Do we have any new classes that we need to precondition? We got this and precondition checks. Good. All right. Um, Exceptions. So do we catch anywhere? No. Do we throws? We do, but that's okay, it's already done. Okay, we don't actually do anything with the resulting exception for these, so that's fine. Cool, good on that one. To-dos. No to-dos. Love it. We didn't have any classes to know this. Suppressions. Okay, we're good on that, good on that, good on that, good on that, good on all these so far. Okay. All right, those are scoped as tightly as possible, and then we've got line lengths. Anything go over 130. Nope. All right, so we're done with those unit tests. All right, let's commit, and now what we're gonna do is get a diff until that the commit where we started. So let's compare not these commits, compare these commits, and let's just do some sanity checks. Okay, and it's pretty much all that. Why won't this drag over? Hmm, bizarre. Okay, looks good. Um, okay, that's not fun. Maybe there's a different view here. Look by the left, side by side, inline. Okay, so we've got this all looks reasonable. Things in place. Same deal here. Okay, nice. That's a small touch up. Yeah, this didn't really change this much. We just copied that over to here. We renamed the file is what we did. Cool. Unit test there. Unit test there. Oh, query result extension, unit test. We don't have a space here. Cool. Yeah, nothing sticking out. No ball error query. Okay, things good here. So far, let's compare. Okay, so we use this in both. Does this make sense to extract into its own, like make this internal? I'm gonna go with no. This is the sort of thing, in my opinion, we should do later. So like, yes, maybe there's actually even like a quote unquote production scenario, not just a test scenario or something where you want this kind of comparer. But in that case, like I've made this note here, this is not production. I did no due diligence here. And so that means this is basically this is just part of the test code. This isn't intended to be like a shared comparer or a multi-purpose comparer. And as a result, yes, the code is the same between the two test classes, the query result extension test and the query result node extension test. The code is the same, but that's like by happenstance. The two tests happened to need the same code. But if at any point one of the two tests changes and needs to have this comparer do something in addition or something less complete than what it currently does, now we've shared the thing, and so we now have to accommodate all of the callers, and that's just unnecessary in test code. Like unnecessarily sharing test code just causes maintenance nightmares and actually makes it harder to test in the future. So my take here is we should keep these separate at the moment. If ever we do have a general purpose comparer for this for case insensitivity, we should use that general purpose one in both of these test classes. And then um, in the event, like I said, where we need to maybe change the behavior of that because it's on there's some test specific behavior we need, well, then we're back to this. Whichever test class has the test that needs that specific behavior, we just create a new comparer, like we did with mock query results and stuff, for example. So this is, to me, totally reasonable that it's identical code. It's syntactically identical, but semantically, it is specific to the test that's calling it, actually. And we just did all this, so I'm not going to go through it again. Here, these are, oh, I see. So this view is going to be terrible. Let's do write file only. Didn't know either, looks good. And we create something that has a value. One. And this, like I said, we renamed, so none of this code has changed actually. You can actually see that because we're not using any of the, we're not using the factories for first or default. And here we just updated, I just updated some to-dos. Good deal. Pretty happy with all of that. So next on our list, I'll give some context here. Um, I have these weird things. Uh, Configured awaiter, configured task source, configured task awaiters, task wrapper, etc. So over in query context, uh, we want all this covariance. It's all covariant. It should be covariant. Um, and so the fascinating. And so here we actually this was my motivator for making query result itself an interface and query result node as a result also an interface. And I had a whole thing with query result, and I eventually normed on this either. I was gonna, if I had an alias available, I would have used an alias. So having this as a pseudo alias, I think works nicely actually. The point is though, none of that matters. We just use task because task is concrete, can't be covariant. So we need an interface. Well, there's no interface. So I created just this interface, and I started with just the getawaiter. And I knew more or less nothing about all this stuff like a month ago, and so I know slightly more than nothing now. Still pretty darn close to nothing. Um, but I did know that there was duck typing involved, and so all I needed was a method called getawaiter that returned something that implemented the thing that the notification completion stuff and had these two things duck typed. So I needed to return a type that had these two members and also implemented something that implements I notify complete directly or indirectly. So that's what I did. Then also realizing, hey, this context capturing thing is pretty darn important for a lot of situations. Um, so I couldn't just get away with um, just the awaiter aspect of tasks. I also needed the configure await portion. And same deal, let's turtles all the way down on this. There's like task, which is covariant, which means that I can't just use the standard task awaiter. I need an interface for that. I can't just use the configured awaitable. I need an interface for that. All this had to be covariant and go all the way down. So that's where we're at, or rather, where I'm at right now. I wrote all this stuff. I didn't write any tests for it. That's not exactly true. I wrote some playing around tests to try to get stuff working, but I don't have any like actual tests that I'm using um, that are like automated and good and repeatable. So I'm gonna be writing those. That's the game plan. So um, we're gonna do that and code review it all and all that stuff. So um, and I guess the other part is like to me. I don't think I'm gonna test any of this stuff. I'm gonna test it at the task level. I'll test maybe like um, error conditions, specific failure tests. Maybe I'll test at lower levels, like the task awaiter, the configured task awaiter, or something. Um, but I think I'm just gonna test it all at the task level because so much of this stuff depends on so like critical notify complete if unsafe uncompleted is called versus if uncompleted is called is entirely contingent on how the task is being leveraged. So I can write code that just like does a nonsense assertion on top of this, but it's going to mean nothing because really what I'm trying to make sure is that the task that returns the thing that implements notify completion, that task is doing the right thing in the right situations where async await is being used. So It's much more about making sure the complete picture is there because at the most basic level, all I'm really doing is passing through to existing stuff, to the existing .NET code. So I haven't 100% made up my mind, but I would say I'm like 85% on that I'm only going to be doing it at the task level. So let's see what happens. Uh, so yeah, task. Wonderful. Let's do our code review, comment line. We got it. Um, we've I think I've already done all the separate files, so we should be good there, but no new files needed here. We're in the right namespace. We don't have the unused namespaces. Um, we're an interface, so we don't need sealed. There's no read-onlys or anything like that. We don't have preconditions. It's not concrete. Exception documentation. We're just inheriting the documentation. So, and same here. Inherit doc. The is task of t result dot configure await. So whatever task does is what we want to be doing. And in our concrete implementation, we'll also check that. To-dos, no to-dos left, love it. No, this should all be public, not internal. Again, this isn't concrete, so there's no this. Not concrete, so no exceptions. Do we have any suppressions? No. Line lengths look good. Unit tests. We can't unit test an interface. We'll do unit tests on the task wrapper in a second. All right. So everything's good there. It says I changed something. What the heck did I change? The inherit doc. What did I change over here? Oh, I didn't commit that from before. Let me go ahead and commit that. Um, and now get back over here. I don't. Maybe I had a white space change or something is what we did. I don't know. Okay. So task looks good. iTask looks good. Let's do the task wrapper. So we need a comment line, no comment line. Actually, what I'm going to do at this point is I already know this depends on all the stuff in compiler services, and I'm going to want to know the exceptions and all that stuff. So I'm going to just head over to the compiler services stuff, and I'm going to start with the interfaces. Let's just do it. So task awaiter, critical comment line. Take a more systematic approach. We got our comment line. We didn't need any namespaces, which is pretty neat. Interface, we don't have a lot of the normal stuff here. Preconditions, we don't have exception documentation, but we already did the inherit doc from both of these, so we're good on that. To-dos, I don't see any. Let's just search, no to-dos. Suppressions, no suppressions. Line lengths look good, no unit tests because it's an interface. All great. All right, here. I've done nothing on this one so far, so let's do this. Comment line, namespaces. We don't have any using statements, concrete types. So now we're in exception documentation. So I hope I can get an inherit doc on here. Uh, Dref equals configured task awaitable. Nice. Get awaiter. All right. And we're just going to be passing through, I think, if I remember right. Anyway, so that's good. So that's our exception docs. We can't see any to-dos, but we'll search anyway. After any suppressions, we'll search anyway. Line lengths look good and no tests because it's an interface. All right, we've done the interfaces. Let's commit and now let's do the task awaiter, because these are yeah. This is more fundamental. So here we go. Comment line. I don't have a comment line yet. That seems to have done some other things in here. That's okay. Comment line. Namespace. This is the right namespace. We don't have any unused using statements. We are sealed. We've got a read-only field. Everything's good so far. Um, preconditions. We got our precondition here. Here, preconditions. I don't know. So C sharp. Let's go T. Let's uncompleted and unsafe uncompleted. So we need both. So this has a argument null. Yeah. So these two will just have to be passed through because they're not precondition checks necessarily. There's something more foundational to the logic of the task waiter implementation. So this is behavior that we're actually hoping to get passed through to us, but we do need to do this precondition check. So let's do that. So argument null exception, so it's null continuation, and I'm going to assume it's the same on unsafe, but we'll just check. Plus basically nothing but check. Hey, look at that. It also throws if for unsafe uncompleted. Okay. So we've done our precondition checks. Now exception documentation, we only have this part because everything else is inherit doc, which is lovely. And we did a good job here already. So now we have to-dos, to-dos, this dot, this. Cool. Call it exceptions. We didn't catch any exceptions yet. Any suppressions? No suppressions. How about line lengths? We have a line length issue here. Let's fix that. Cool, that's line lengths. And this is where we would unit test, but again, yeah, we'll do the failure test. Let's do failure tests. So this is system runtime compiler services. And this is the task awaiter wrapper. I'm going to call it failure test because not intending to actually test any of the functionality. So what do we have? We have initialize with null awaiter. So task awaiter, that's a string. Completely forgot that's a struct. So glad we're testing. We can't provide a null, so this is all nonsense. I forgot to put the placeholder in here. All right, so we don't need to test that part. What do we need to test? We need to test uh, on completed null continuation. So we'll have a new await task awaiter. um, task awaiter wrapper, and then we will say wrapper dot on completed null, and we should assert this is going to throw argument null exception. Oh, I saw the spread. I thought it failed for a second. Okay. And then we got the same, but for unsafe on completed, public void, unsafe on completed, no continuation. All right. Cool. So those are our failure tests. I just want to see. So when would it be not initialized? What would that mean? I don't know. Okay. So we're good with that now. So we've got the unit tests, and now let's code review the unit tests. We need a comment line. It's in the right namespace. We don't have any unused usings. It's sealed. We don't have any non-test classes, so we're good on most of this. Let's check to-dos. No to-dos. Catch and throws. We don't do anything with thrown exceptions. We're good. Let's check our scoping. That's scoped. That's scoped. All right. And no line length issues. Cool. We are good. So that was task awaiter. Uh, so this is configured awaitable. So this one is next. This was more fundamental, foundational. So we'll start with that. So we've got a comment line. That's how we know it's left. It doesn't have a comment line. Namespace is good. We have no using statements. We are sealed. Our field is read only. Recondition checks. This is also a struct. Cool. So we don't need to do any precondition on that. This is going to be inherit doc, inherit doc, and inherit doc, and inherit doc. All right. Sorry, exception documentation is where we're at. So cool. Now skip precondition checks actually. So this doesn't, but these two have the same. This is a task awaiter again. And so this has the same argument, exception tests, checks that we need. Um, okay. So now exception documentation. We didn't need to document anything for this, and these are all inherit docs, so we're good to go. And then to-dos. No to-dos. This dot, did we do that everywhere? Yes, we did. Nice. All exceptions. We didn't catch any exceptions. Any expressions. We don't have any expressions. Line lengths look good. All right, let's do some failure tests. It's going to be the same to failure test those null checks. Um, did I name these? Yeah. So completed, null, continuation. So wrapper is going to be configured, task awaitable wrapper, new, whatever this is. Okay. And now wrapper dot on completed with null. That throws argument exception. And then same for unsafe. And let's run those. Those passed as well. Good. So unit tests. Let's do our code review of the unit tests. We need a comment line. We're in the right namespace. We have no unused namespaces. We're a sealed class. All good. No preconditions needed. No exceptions need to be documented. Any to-dos. No this dot. Exceptions. Did we catch anything? No. Did we throw? We did, but we don't use the thrown exceptions. Pragmas. So that's oops, scoped. And that's scoped. Great. And then line lengths, we just barely made it fit it in. Okay. So we're done with those tests. And now we're on the last one. Comment line. So comment line, we're in the right namespace. We have no unused using namespace, using statements. We're sealed. We have a read-only field. All of this looks good. Preconditions. Configured task awaitable. This is struct. Great. But no precondition checks. Awesome. Did I do this right? I wrote placeholder. Good. All right. So we got to write placeholder. And here, inherit doc. Cool. And then just to double check, can this throw? No. Can this throw? No. Everything's good. You'd love to see it, man. To-dos. No to-dos. this dot. We use this dot everywhere. We did. Look at that. Exceptions. Didn't catch any exceptions. Having suppressions. No line length issues. All right, this is all good. We got some tests right now. Is what we got. We don't actually have any failure tests, so we have no tests to write. All right. So now we're on task wrapper. Let's go grab our comment line in the right namespace. No unused namespaces. So far, so good. It's sealed. We're read only. Preconditions. We have a precondition. Do we want to wrap value task? I feel like that's going to be its um, own class anyway, so we're good for now. Precondition check, no preconditions, no precondition, no preconditions. Great. Exception documentation, yes, we throw argument null. How about here? Configure await. This should be inherit doc. I'm gonna let this bite me before I fix it. You don't actually need a configure await for a type. It would be irresponsible to not have a configure await and to implement a task and not have a configure await. I'm sure this will bite me at some point in the future, but I'm okay at the moment with saying that I should be forcing the implementers, who is me, so me, to write configure await. I'm gonna say that for now, and when it does bite me, we'll fix it then, and I can get mad at myself. But we're good. Okay, those are inherit docs. Um, let's just make sure this doesn't throw, this doesn't throw, this doesn't throw, this doesn't throw. Okay, any to-dos left in here? No to-dos. Um, this dot, we'll use that correctly. Uh, catch anything? We didn't catch anything. Do we have any expressions? Nope. Our line lengths look good, so we're ready for our tests. Okay, now things are gonna get a little bit weird. Okay, so what things are we testing here? What did I already write? Okay, wrote basically nothing. Nothing structured. So let's start with the basics. Initialize with a null task. So we should get an argument null exception. We say new task wrapper string with null. It really makes it look like it failed. All right, what else do we need? Let's put this up. I don't know why I did it in that order. So let's get the awaiter. Uh, okay, so that's this one. So here's the thing I learned um, in all my stuff in my recent learnings. So uncompleted and unsafe uncompleted. I should have given myself links to the things that actually maybe I still have them. No. Feels bad. Okay. So switch our task here. Oh, task uncompleted versus unsafe uncompleted. um, All right, well, that's a bummer. So what happens is, um, from what I remember, if you're a waiter, implement has an unsafe available. .NET will use that. What is it using this for? What is actually happening? Let me start there. So in this test here, this await is going to take all of the is going to take the task returned by this and let it finish, and then say not let it finish, and then tell that task to continue with the rest of the method, which in our case is just the one assert call here. But what it's going to look like is it's not the same, but it's going to be similar to. Let's get something that returns an actual task. Uh, okay, so it would be like saying demo dot continue with um, and then the rest of it. And this continue with is effectively implemented by saying, putting that action in, passing that action into unsafe uncompleted or uncompleted, and the action, this stuff, is what's actually passed in here. Um, so upon completion, what the task is supposed to do is execute this action. Um, so why are there two methods? There are two methods because one of them requires some phrase that I forget, but essentially checking the security context of the call, making sure that the call is that the appropriate security checks are done, and that's going to be the one that's not labeled unsafe. So on completed is supposed to do those checks. Um, that said, the critical. Here we go. I'm just going to move this over here so I have it available. Um, but if unsafe is not, or sorry, unsafe doesn't do those checks, and that's because uh, .NET does those by default. Actually, this is like a historic thing. So on complete, if you only implement notify completion, and you have on completed, that actually means that like you have either special security checks you need to do, or you're like historical code, and you don't have an unsafe variant. So what all this is coming to is basically, because unsafe doesn't do the security checks, and because .NET already does the security checks, .NET is going to the runtime is going to prefer, the compiler actually is going to prefer calling unsafe because it will be more efficient. However, if you don't have unsafe available, then it will use notify completion to call on completed. So back over to our task awaiter here, for example, we could have implemented um, this I notify completion, and that will be sufficient. Um, you can see that in the tests. That will be sufficient to still be used with await. There's not an issue. However, we are not able to simply duck type this. So throwing this over here and actually having none of these. So now we have the onCompleted. Um, well, don't I feel like a fool? Yeah, there we go. Um, I task waiter does not implement I notify completion. So it uses duck typing for a few things. It uses duck typing for the method itself, get a waiter, and it uses duck typing for these two members, but it also requires that you implement one of the two interfaces, or actually that you implement I notify completion. And since I critical notify completion also implements I notify completion, then you are meeting all the requirements there if you implement I notify critical notify completion. But critical notify completion is what gives you access to the unsafe on completed. So there's no way to get an unsafe on completed on your awaiter without also implementing critical notify completion. So the only way to get the efficient way, the .NET blessed efficient way to notify notify on completion is to end up with both methods, unsafe on completed and safe on completed. Despite that, unsafe on completed and on completed. Despite that, on completed is basically superseded in all ways at this point. Um, so where that leaves us is we need to somehow test both. And so what we'll see in this test, um, if we do code coverage, let's just test. What we will see is that the task awaited wrapper only unsafe is called, and that's our expectation. If unsafe is available, .NET is going to use unsafe because .NET's already doing the security checks, and unsafe is therefore more efficient overall. Calling on completed would end up with two of the same security checks, so it's not necessary to call. So we can get most of the way there by just this simple test. So let's give this a name. Unsafe on completed. Um, and let's do a couple other things like okay. All right. Um, let's go ahead and move this up. Let's make sure everything's nice and in order. So a couple of things to note here. First, we need a task wrapper, so we need a task to wrap. So we need this foo here. Um, here value implementation, for example. We need this method here so we can use something built into .NET to get a task because we're actually wrapping stuff. We're not actually implementing a task, but we want to be correct in our wrapping. So we need to make sure that we've covered everything and that everything works as expected. So why task delay? Why not just task from result? Well, task from result um, is going to return a completed task. And so on completion is not called for a completed task. The state machine is smart enough to know it's already completed, so it's just going to continue with the rest of it. So we need something that is inherently not started yet, or sorry, not completed yet, so that when the task, when the state machine for await actually calls everything, it does in fact call on completed. Um, so we need something, uh, and let's write that. And here we can't use task from result because that returns a task that already completed. We need to use something that starts out not completed so that the state machine will actually call the uh, on completed methods. Great. So everything should still succeed now. Hmm? Okay. Okay. We'll fix that up in a second. Remove that comment, put it down here. All right. So again, let's get back to it. Let's run these two, these two. And what we will see is what we had just a minute ago. So we got unsafe uncompleted call. Now the question is, how do we get safe uncompleted to be called? Um, and the answer to that is you don't. If unsafe is available, .NET will call unsafe every time. So the only way to get .NET to generate code when it sees the await to generate code to call on completed instead of unsafe on completed is to not implement critical notify completion and only implement notify completion. So we have no way to convince .NET to do this. So my plan to write this test is to pull some generated code for await, and so basically take this method, throw it into a decompiler to get the generated code, um, and for that state machine, for the state machine that await actually generates, the compiler generates for await. And then we're going to just simply update that state machine to change when it calls unsafe oncompleted to call safe oncompleted or just oncompleted. So let's do that. And I would say this is my favorite. This is the one I'm aware of. This is what I'm going to use to do that decompilation. So I'm going to take this stuff, uh, this stuff, we can probably just take all of it and whoops, put it in here. And we don't need most of this. We don't need this entire test. Um, we do need task and task wrapper. So we'll have to grab those. Um, Figured task awaitable. I task awaiter. Did we already have that? Okay. Um, and I didn't throw in task wrapper yet. So task wrapper. All right. Task awaiter wrapper. So basically gotta pull everything in. That's okay. Whoops. And configured awaitable wrapper. Gonna assume it's not about this. Let's check. Yes, of course it is. Cool. All right. Now the only problem now is that it doesn't have the cert. So let's just add that real quick. So add cert. Over static void r equal. Whoa. Object for expected object actual. Great. So it compiles now. So here's what we've got. We want to find our method. Unsafe, uncompleted. Actually, we're implementing safe uncompleted. So safe uncompleted. Hey, why didn't it recompile? Okay. So here's our method. Here's our test. And so it's calling this generated state machine. And here is where it calls unsafe uncompleted. So what we're going to do is we're just going to copy this state machine over to Visual Studio. We're going to say we copied this from the decompiled code, by the generated code, and that the only thing we've changed is 08 unsafe uncompleted. A little concerned about this part here, but we'll just go with it for now. Okay. All right. First of all, this is now a test method. Let's get that out of the way. And then the rest of this is um, we got to change the compiler generated names because they're not legal. All right. Now this, we're just going to call that builder. All right. Here, we're going to call this self. This we're going to call state. Getting closer. Why is this map? Non-nullable field must contain a non-null value when exiting constructor. Consider adding required. Yeah, I'm not exactly sure how all that's supposed to work. We're just going to put an exclamation point, maybe. No, we're going to put expression. Why is nullable? Supports value type that can be assigned null. It's costing nullable is not attribute class. Nullable attribute. Oh, well, probably then we're gonna get rid of all these problems. We're just gonna remove these. We're gonna have to remove them. Hmm, bizarre. We gotta do both, I guess. Okay, no problem. Now we've got this. Let's replace that with provided value. Here, we're gonna replace that with value. Okay, we're getting closer. And then this, I don't know what to call this. Let's call it S3. And then let's call this one U1. All right. So now it compiles, but what we actually wanted to do was make this all the safe version. Now let's run this, make sure it passes. It passes. Now let's analyze only that one, make sure it calls onCompleted. Calls onCompleted instead of unsafe onCompleted. Perfect. And so now we run all three of those tests, we should get 100% coverage on task awaiter wrapper. 100% coverage. Awesome. Now, let's note what we did for the next person. So all right. Slightly modifying code from the prior generated state machine for unsafe uncompleted. It, the compiler generated code has been modified the following way. One, member name identifiers have been renamed to uh, legal. Two, nullability issues have been suppressed, removed, or what's the null C sharp nullable exclamation mark exclamation null forgiving or forgiven. And then three is this part. Oh wait, gotten. Let's go back here. Unsafe, uncompleted. Line has been changed to this. The intent is to have a test which covers the case where uh, safe on completed variant is called while still providing colors the more efficient unsafe variant. All right, doing good. And then I'm just gonna write down this URL because I'm gonna need it later. Because we're gonna need to do safe and unsafe for this stuff too. But what we can do now is, oh, hey, I already have this comment. If it says falling body. Yeah, I said the same thing. Good. Um, no, we don't need to do that. This is its own. What we need to do is what I did down below and say is our slightly modified state machine. Following. Okay, good. Now, I think we can get rid of this. The reference by itself. Okay, yeah, so we can get rid of all this. All right. Okay, now where are we at? So we have total coverage for, let's see. All right, we have coverage for get a waiter, but we don't have coverage for anything around configuring a wait. So let's go refresh ourselves on what that looks like. iTask has I configured awaitable. I configured awaitable. And so now we have configured awaitable wrapper. And then configured task awaiter wrapper because we need to give it a configured task awaiter. So this is identical to the task awaiter wrapper. The only difference is that this is taking well, let's look. This is taking a task awaiter, and this is taking a configured task awaiter. So we need the exact same tests for this, the stuff we just did around safe versus unsafe, that we did for this, but we also need to have the two cases where the context is preserved and where it's not preserved. So let's learn some things first, and I'll probably have to remind myself when we're coming to the end. So gonna go through some stuff, but I'm probably gonna have to remind myself of this stuff tomorrow anyway. But it's good to get some reps. So this is how we can actually test that the configure await is working. Configure await true means that we try to return to the same synchronization context. Configure await false means we don't try to return to the same synchronization context. And for clarity, this is what a synchronization context is. Well, that's not at all what I wanted. So you can put callbacks into it, is what you can do. You can schedule delegates. And so what happens is, if you remember that on completed stuff, where I was talking about the continue with, so this is equivalent to saying this stuff dot continue with assert r equal. And again, it's not equivalent. We can see that because it doesn't call continue with in here. It calls await on completed. It does all this stuff. But what happens in here is that the action that is being continued on, it needs to get scheduled on some task somewhere. And that's what the synchronization context does. So the synchronization context gets sent that delegate, basically. Um, and when it gets sent that delegate, it's going to schedule it. So um, the default task scheduler is going to do something like put it in a queue, and then that queue, there's some background thread that's going to go through that queue and put it on like a thread pool thread or whatever the heck the default scheduler does. But what we're going to do, so if you use the default context, that's kind of what happens. If you don't use the default context, you can do other stuff. Like here, what I've implemented is that it always runs on one thread. All we do, you can enqueue to the concurrent queue with a bunch of stuff, but we're only going to execute that stuff in a single threaded manner. So that would mean that you're able to do the UI thread is similar to this, but that would mean that you're able to do things like have thread local storage and stuff. Um, and your method that is awaiting would be able to rely on thread local storage. So if we did something like have thread local storage in here in this first part, and then we said configure await true, we could continue relying on that thread local storage that we set up here. But if we say configure await false, which is the default, when we get to here, we don't know that we're actually this same synchronization context. And so there's no guarantee, and in fact, it's like unlikely that you'll end up on the same thread. And so you won't have that thread local storage. And the benefit to having configure await true, maintaining the synchronization context, is that you can do things like take advantage of thread local storage if that's something that you require for some reason. Most things don't actually require that. But I think I said a minute ago, configure await false is the default. That's not true. Configure await true is the default. I got that backwards. But if you, back to what I was saying, the if you don't need things like thread local storage, or you don't need the same synchronization context, if you say configure await true, then it's going to try to put you back on the same synchronization context. And so if you have a task, if you have some code that is asking to be put back on the same synchronization context, but that synchronization context is currently in use, then you won't ever be able to get back to continue back on that synchronization context, and so you'll end up in the deadlock. And this is the sort of notorious ASP.NET UI thread deadlock stuff. So if you use the UI thread to schedule some work to await something, and you don't configure await false, then the continued with code, everything after the await, is going to try to get back to the UI thread, but it won't be able to because the UI thread is not interested in doing your work. It is interested in handling the UI. And so you will actually never be able to get back there. And also the UI thread will, I think, block as well because it's waiting for this task to continue. And so you got the UI thread blocked, waiting for something that's waiting for the UI thread to become unblocked. You end up with that deadlock. So we need to implement configure await because I want to be able in my code to be able to use my I tasks to configure await because I don't want to have those deadlocks. And so all of this was setting stage for the tests we need to write because we're going to need a context a synchronization context that in some way preserves state so that we can check that we have or have not maintained the same synchronization context. So yeah, that's the game plan for tomorrow. That's all for today. Let's commit anything, nothing to commit. I'm gonna push all my changes. And we're gonna